guys, this is Lekana. Welcome back to my channel. Today I'm here with a new topic, that is threads. The agenda of today's topics are introduction, benefits, process and threads, types of threads. Introduction. A thread is a basic unit of CPU utilization. It consists of thread ID, program counter, a stack, a set of register. A thread is also called as a lightweight process. Every process they contain a single thread. By default, they contain a single thread in the process. Why we need threads? Whenever a process has multiple tasks to perform independently of the others, at that time we use this threads. Example, in a word processor, in a web server, in a web browser. In web processor, imagine we have three threads. One thread, it will check the spellings and the grammar, while the another thread, that is second thread, it will check the inputs, and the third thread, it will load images from the hard drive, and the fourth, it will periodically automatically backups the file been edited. In the web server, multiple threads allow for multiple requests to be served simultaneously. In the web browser, one thread is used to display the image and the other thread is used to retrieve data from the network. And you can see this image. You have a single threaded process and a multi-threaded process. In single threaded process, we have a data segment. In this data segment, we will store the instructions which are given to this process. In the data segment, we store the global variables which we will be using throughout this process, and in the file segment we have the files, and register will store the register. In the stack, all the functions will be written there. This is single threaded process, but in this single threaded process, if this process blocks, then the CPU should wait until this process is unblocked. That's why this is not very advantageous to us. It will take more time to execute. That's why we have this multi-threaded process. In this multi-threaded process, we have multiple threads. You can see in this image, we have three threads. If one process blocks, then another process will be executed. What does happens in this multi-threaded process is, the process is divided into tasks, and the task is called as a threads. They'll divide the job one by. For example, if the first thread fails or blocks, then it will go to the second thread will work. Like that, if we use this multi-threaded process, the execution time will be less, and all the threads are simultaneously, they work together. Simultaneously they'll work, as we said in the web server, a thread which allows multiple requests to be served simultaneously. Next, we have differences between this process and thread. The primary difference is that threads within the same process run in a shared memory space, while process run in a separate memory space. Threads are not independent of any other like processes. As a result, threads share with other thread their code section, data section, and OS resources. But like process, a thread has its own program counter, register, set, and stack. You can see this multi-threaded process image. You saw now. There are three threads. All these three threads, they have same code data files. But the difference between this thread and this process are, these threads, they have same process with shared memory space, where this process, they have separate memory space. And the similarities is, they both have their own program counter, register, stack. And the benefits of these threads are, we have four benefits. One is responsiveness, resource sharing, economy, and one more is scalability. First, we have this responsiveness. In responsiveness, one thread may provide rapid response while the other threads are blocked or slowed down during intensive calculations. And second, we have resource sharing. By default, threads share common code, data, and other resources, which allows multiple tasks to be performed simultaneously in a single address space. In economy, creating and managing threads is much faster than performing the same task for processors because they have context switching. Means switching to the different multiple threads, it's easier between threads. The context switching between threads takes less time. And one more, we have a scalability, in that we will use multi-processing where the threads can access it very fast. Next, we have types of threads. We have two types of thread. One is user level thread and one is kernel level thread. In user level thread is a type of thread that is not created using system calls. The kernel has no work in managing the user level threads. User level threads can be easily implemented by the user. In case when user level threads are single-handed process, kernel level threads manages them. You can see the image of this user level threads. And the advantages of user level threads, disadvantages we will discuss in this. um, First, we have advantages. Implementation of user level thread is easier than kernel level thread. Context switching time is less in user level thread. User level thread is more efficient than kernel level threads because of presence of only program counter registers at stack space. It has a simple representation. Disadvantages of user level threads. There is a lack of coordination between threads and kernel. Increasing in the case of page fault, the whole process can be blocked. Next, we have kernel level threads. A kernel level thread is a type of thread that can recognize the operating system easily. Kernel level thread has its own thread table where it keeps track of the system. The operating system kernel helps in managing threads. Kernel threads have somehow long context switching time. Kernel helps in managing of threads. Advantages of kernel level threads are it has up-to-date information on all threads. Applications that block frequently are to be handled by the kernel level threads. Whenever any process requires more time to process, kernel level threads provide more time to it. And the disadvantages of kernel level thread is in kernel level thread is slower than user level thread because this context switching takes time. In this kernel level thread, implementation of these types of thread is a little more complex than a user level thread. You can see the image of this kernel level thread. In this video, we have learned what is threads and why do we use threads and what are the benefits of threads and types of threads. Thank you for watching my video.